welcome back to linear algebra. Let's jump into Anki to begin with. If A is an invertible matrix, how is the transpose of its inverse related to the inverse of the transpose of A? How is the transpose of its inverse related to the inverse of the transpose of A? I think it's the inverse of the transpose of A equals the transpose of the inverse of A. If R is the reduced Royal echelon form of a square matrix and R has no zero rows, then what must be true of matrix R? It's I. How are the rows of a matrix A affected if it is multiplied on the left by a diagonal matrix D? If it's multiplied on the left, basically you're going to multiply each row through by successive diagonal entries. Yeah, nice. All right. I'm going to go ahead and grade what I did yesterday, and then I'll be back to recall what I did. Got everything from yesterday correct except for the one that I knew I couldn't do. I skipped. Basically what I was missing were these are trig identities, that they're double angle identities. So cosine squared minus sine squared equals cosine 2 theta, and this is negative sine 2 theta. That is negative sine times cosine, and then cosine squared minus sine squared again, cosine 2 theta. So this rotates an angle through the origin about the angle 2 theta, because cosine, sine, cosine, negative sine, sine, cosine, if it's just theta, we'll rotate it about the angle theta around the origin. So, okay, and I'm gonna jump back and continue working, and I'll be back to recall what I did in a little bit. Okay. Today I did one review problem from 1.5. It was basically to find the inverse of this matrix where K is all non-zeros. And so basically just used Gauss-Jordan elimination, solve this. I don't know if this was really worth the time to do, but whatever, we did it. And that's pretty much it for today. So talk to you tomorrow. See ya.